Hey guys, these are lesson 5.1 notes. This is our unit that we're starting over polynomial functions. We are going to first find zeros, which are our x-intercepts of a polynomial function, when we have the function in factored form. And this is just like when we had our quadratics in factored form, except we are going to have multiple answers with a polynomial. We'll first set each piece equal to 0. And the second piece here, and then that third piece here. We set them each equal to 0 and we solve them respectively. The first one we're going to get x equals -4. On the second one we are going to get 3x equals -1, divide by 3, and we get -1/3. And then on this last one we will add 9 to both sides. Get x squared equals 9, and then of course we have to take the square root of both sides, which includes that plus or minus 3. Now for our final answer, we need to pay attention that this did originally say that that was 4x plus 4 squared, and we are going to say that has a multiplicity, and you will see it MULT 2 is how it'll be referenced, multiplicity of 2. That just means that there were actually 2 factors of x plus 4, and that tells us that the graph actually touches the x-axis and does not go through the x-axis. Then the function goes through the x-axis at -1/3, and it goes through the x-axis at positive and -3. So if we wanted to, we could put that all together and draw a sketch of that function. For example 2, we set each factor equal to 0, so the first one is already done, and honestly I probably should just move that over so it's out of our way. Then we're going to have 3x squared minus 4 equals 0, and we are going to have x plus 2 equals 0, and that one's easy to solve, so I'm going to go ahead and get it out of the way. Now notice it says we're going to have to learn how to rationalize a denominator in this example, so that's going to come from this problem that I'm currently adding 4 to both sides, and you probably think it looks pretty simple, and it's really not that bad, but it does require an extra step. So I'm going to divide by 3. I get x squared equals 4 over 3, and once again I need a little more room, move you out of the way. And I'm going to take the square root of both sides, and when I do so, I get plus or minus. The square root of 4 is 2, but I can't take the square root of 3 because 3 is prime, and I also cannot have a square root left in the denominator. So I have to do something called rationalize the denominator, and I'm going to multiply both the numerator and the denominator by the square root of 3, and in doing so, the square root of 3 times the square root of 3 is actually 3, so I don't have a radical in the denominator anymore, and in my numerator I'm just left with 2 times the square root of 3. So it's kind of like it moves upstairs in a way, because that's where it ends up. Depending on what's up there, though, it could kind of get washed out. If I was multiplying it by another radical, then I wouldn't see the radical of 3 anymore, but in this particular problem it almost has this effect like it's moved up. So our answers were, let's make sure we remember what they all were. We had x equals 0, and we had plus or minus 2 radical 3 over 3, and we had -2. I'll let you guys try the U-tries. In example 3, honestly, the only thing I can tell you is this is where we're going to use technology. So you would simply enter this into your calculator and estimate where the graph crosses the x-axis. So there's not a lot I can show you here on these video notes over that. Okay, next, finding zeros by factoring. These are problems where you are going to factor by something called grouping. This is example 4, factoring by grouping. And as long as these numbers create the same ratio, so putting this one first over this one, so -4 over 4, and then this one first over this one, 36 over -36, as long as they create the exact same ratio, which they do, they're both equal to -1, that means you can factor by grouping. It's kind of like a little clue that you can do it. So what you do is you first find the GCF out of the first 2 terms and the GCF out of the second 2 terms. The GCF in the first 2 terms is 4x squared. And if I divide this first term by 4x squared, I'm left with x. And if I divide this second term by 4x squared, I'm left with 4. Then, ideally, when you do this again, you should get another x minus 4 to remain after you divide out the GCF here. That's how factoring by grouping should work. So the GCF here is negative 36. Yep, there's my mistake. You guys are probably catching it. That is not a 4, Miss Elliott. That is a 1. There we go. Okay. I went to divide, and I knew that I wasn't going to get a 4 there if I divided 36 by itself. Okay. So the GCF here is 36. Negative 36, and when I divide negative 36x by negative 36, I'm left with x. When I divide 36 by negative 36, I'm left with negative 1. I knew that I wanted to choose negative 36 because I knew that negative and that negative would turn into that positive that's right there. And remember, I told you the goal of factoring by grouping is that this and this will match. So you sort of like have a goal in mind when you factor out the GCF of the second one. Now, since they both have an x minus 1, I'm going to take an x minus 1 out of both of them. And then if I take an x minus 1 over here out of this whole term that's happening right here, I'm left with a 4x squared. And then if I take an x minus 1 out of this whole term that's technically happening here, I'm left with a negative 36. Then I set each piece equal to 0. And after I set each piece equal to 0, I'm left with x equals 1. Here I'm left with 4x squared equals 36. I divide by 4. I'm left with x squared equals 9. I'm about to get a very nice answer here. I'm going to take the square root of both sides and get x equals plus or minus 3. And those are the zeros of that function. All right, next. Find all the zeros of 5x to the fourth plus 17x third plus 6x squared. Our first step is always to divide out by a GCF. And so here it is x squared. X squared goes on the outside. I'm left with 5x squared. Then I'm left with 17x. And then I'm left with 6. So our next step is going to be to factor the inside of this equation, this polynomial, just like in our quadratics unit. So I'm going to go ahead and set up my 2 parentheses. I know that this has to be a 5x, and I know that that has to be an x. And there are only so many factors that multiply to equal 6. We have 1 and 6, and we have 2 and 3. This polynomial is all positive, so it should be easy to find the one that works. Let's go ahead and just try 1 and 6 and see what happens. And I would get 1x, and I would get 30x, and that's definitely not it. I'm going to go down and attempt, and I still had my giant eraser on right there, and I just totally wiped out everything I had written in here. Hang on 1 second. Okay, so I'm going to go and actually try 2 and 3. So let me get my colors right. So 2 and 3 would give me 2x. That would give me 15x. And sure enough, 2x and 15x do add together to equal 17x. So now I've got my factors, and all I have left to do is set them equal to 0. And let me move him out of the way just a little bit. And now I'm going to say that here x equals 0, but it has a multiplicity of 2 because it did have that square there. This is going to be 5x equals negative 2. Divide by 5. And then here I'm going to get x equals negative 3. So those are my zeros. All right, finally, on this last problem, the only GCF I have is an x, and that probably makes you a little nervous because you're left with 7x to the fourth. Okay, and it does look like a little bit of a hairy problem, but here's the only thing that you need to do. You're going to split it up just like you would be doing a factoring of a quadratic, except that instead of just putting 7x here in x, you're going to put 7x squared and then x squared. And then you're going to finish off the problem just like normal. You can do box method or whatever method you want to try. We need 2 numbers that are going to multiply to equal 20, and they both need to be negative because we have my negative term here. So if the 2 numbers need to both be negative, we could try, I don't know, negative 10 and negative 2. and I look and I know I need to get 72, and if I had to put a 10 here, I will be multiplying that by that 7. That could quickly get me to 70. So before I even try that out, I'm going to switch them around, just knowing how multiplication works. And sure enough, look at that. That's negative 70x squared, and that's negative 2x squared. And that perfectly adds to give me negative 72x squared, which is what I want. So that is perfectly factored. So I get my negative 72x squared. Sure enough, this equals the positive 20 that I wanted. And we know that 7x squared times x squared would give us the 7x to the fourth that we want. So now I set each piece equal to 0. That one's done. Set this piece equal to 0 and set this piece equal to 0. This will be 7x squared equals 2. Divide both sides by 7, and I get x squared equals 2 over 7. I have to take the square root of both sides. I get plus or minus the square root of 2 over 7. This is technically, here's where it gets a little tricky, the square root of 2 over the square root of 7. We're not allowed to have a radical in our denominator, so we multiply both the numerator and the denominator by the square root of 7. My final answer here will be the square root of 14 over 7, because the square root of 7 times the square root of 7 is 7, and then in my numerator I get 14. And then finally over here, we have x squared equals 10. We take the square root of both sides. Don't forget your plus or minus the square root of 10, and we can't break down the square root of 10 at all. And the rest is just you tries. Try them out if you've missed these notes, and then you can check in with me or someone who did the you tries in class to see how your answers are. All right, thanks guys.